In this section, we'll be dealing with compound probability. How do you find the probability of event 1 and event 2 happening? If you have to find the probability of event 1 and event 2, multiply the probabilities of events 1 and 2. For example, if you toss a regular penny 3 times, what are the odds of it landing on heads 3 times in a row? Well, one way to think about this is to construct a tree diagram. So the first time you toss a penny, it could land on either tails or heads. Suppose it lands on tails. If you toss it again, once again, it could land on either tails or heads. If it had landed on heads the first time, then it would have been able. Then the second toss, it could have landed on tails or heads as well. Suppose that it landed on tails on the second toss and tails the first toss. Then on the third toss, it once again could have landed on either tails or heads. If it had landed on heads the second toss and tails the first toss, it could have landed on tails or heads on the third toss. And if it landed on tails the second toss and heads the first toss, then on the third toss, once again, it could have landed on either tails or heads. And finally, if it landed on heads the second toss and heads the first toss, it could have landed on tails or heads on the third toss. So what we have is multiple branching possibilities. One branch that might have occurred would have been the tails, tails, tails branch, or that the penny had landed on tails 3 times in a row. Another possibility would have been the tails, tails, heads branch. So this is where the penny landed tails in the first toss, tails in the second toss, and heads in the third toss. The penny could have landed on tails the first toss, heads the second toss, and tails the third toss. Or it could have landed on tails the first toss, heads the second toss, heads the third toss. Or it could have landed on heads the first toss, tails the second toss, tails the third toss. Or it could have landed on heads, then tails, then heads. Or it could have landed on heads, then tails. Or it could have landed on heads, then heads, then heads. So the odds of it landing on heads 3 times in a row are 1 out of 8, because there are a total of 8 possible outcomes. As we saw over here, are 8 possible branches, and only one that we want, which is the heads, heads, heads branch, or the heads, heads, heads outcome. So the odds are 1 out of 8. There's another way of thinking about this without drawing a tree diagram, because when the probabilities get too large and the outcomes become too many, then the tree diagram becomes unwieldy. We know that the possibility of a coin being landing on heads on the first toss is 1 out of 2, because it could be either heads or tails. The possibility or the probability of it landing on heads the second time is also 1 out of 2. And the probability of it landing on heads the third time is also 1 out of 2. But the probability of it landing on heads the first and second and third time is 1/2 times 1/2 times 1/2, or 1 out of 8. So we get the same result as if we had drawn a tree diagram, but this is a lot quicker if you know the math behind it. What is the probability of picking an ace and a 10 from a deck of cards? After picking the first card, you replace it, you put it back. We'll use the same reasoning here. The probability of picking an ace is 4 out of 52, or 1 out of 13. And the probability of picking a 10 is also 4 out of 2, or 1 out of 13 when you reduce it. Because we want an ace and a 10 from a deck of cards, we're going to multiply. So 1 out of 13 times 1 out of 13 gives us the probability, which is 1 out of 169. So the probability of picking an ace and a 10 from a deck of cards is 1 out of 169, or something very small. Let's take a look at this question. So the probability of picking a green marble, a red marble, or a blue marble from a bag of marbles is 1 out of 5, 1 out of 3, and 2 out of 9, respectively. If a person picks 3 marbles in random from the bag, what is the probability that he or she picks green and a red, but not a blue marble? The probability of picking a green is 1 out of 5. The probability of picking a red is 1 out of 3. And the probability of picking a not blue is 7 out of 9, if you remember this from the previous section. So we want something that's not blue. If the probability of blue is 2 out of 9, the opposite of that is 7 out of 9, because you subtract 2 out of 9 from 1. Since we want a probability of green and of red and of not blue, we're going to multiply those together. So we're going to do 1/5 times 1/3 times 7/9, which comes out to 7 out of 135. Here we're always replacing the marbles once we pick them. How do you find the probability of event 1 or event 2 happening? If you have to find the probability of event 1 or event 2, add the probabilities of events 1 and 2. For example, suppose that you have 5 white shirts, 4 red shirts, and 2 green shirts in a drawer. What is the probability of picking a white shirt or a green shirt? So we have 5 white, 4 red, 2 green. We don't want the red shirt. Since there are now 5 white shirts and 2 green shirts, the probability is 7 out of 11, because it's 5 out of 11 for picking the white shirt and 2 out of 11 for picking the green shirt. So there are now 7 shirts that we want, and it's 5 out of 11. Or we could have subtracted 4 of 11 from 1. So another way of thinking about it algebraically is this: the probability of picking a white shirt is 5 out of 11, the probability of picking a green shirt is 2 out of 11. Since we're dealing with OR, we're going to add, and we get 7 out of 11. What is the probability of picking an ace or 10 from a deck of cards? After picking the first card, you replace it, you put it back in the deck. So the probability of picking an ace is 4 out of 52, or 1 out of 13 when reduced. And the probability of picking a 10 is 4 out of 52, or 1 out of 13 when reduced. Since we want an ace or a 10, we're going to add. So we're going to add 1 out of 13 to 1 out of 13, and we're going to get 2 out of 13. So the probability of picking an ace or a 10 from a deck of cards is 2 out of 13, which is a lot higher than picking an ace and a 10.